I welcome you for this lecture series where we are going to discuss about case study on total productive maintenance. As we have seen what is total productive maintenance in the last lecture series, we'll continue with that. Just a recap of this TPM. Keeping the current plan and equipment at its highest production level through cooperation of all the areas of organization is the exact definition of this total productive maintenance. So let us see how this can be made. So maintaining and improving equipment capacity, maintaining equipment for life, using support for all areas of operation, encouraging input from all employees, using teams for continuous improvement. So these are all the ways to implement TPM. So downtime losses, various losses associated with areas and planned downtime like startups, shift changes, coffee and lunch breaks, planned maintenance shutdowns, and unplanned downtime, equipment breakdown, changeovers, lack of materials, and reduced speed loss and idling and minor stoppages, slowdowns, and poor quality losses and process non-conformalities and scrap. This process non-conformities and scrap will lead to not only lower the productivity but also cost-wise it will increase the cost of production, cost of any product. So how to calculate downtime, and we have a small formula here, A equal to capital T divided by P into 100. A is availability, T is operating time, planned operating time is P and downtime is D. So reduced speed loss is measured by performance efficiency and it is E equal to C into N divided by T multiplied by 100, and E is performance efficiency, C is theoretical cycle time, N is processed amount, and T is operating time. Next comes poor quality loss measured by rate of quality products produced. So it is the difference between processed amount, quantity, and non-conformities upon processed amount multiplied by 100. So putting together this downtime, productivity, and previous slide, we see about this reduced speed time, speed loss. This AER is collectively the multiplication of all these terms will give you equipment effectiveness. So what is equipment effectiveness? Like the productivity should go higher so that the efficiency is higher. So 85% of equipment effectiveness is expected to give higher productivity. And let us have a small case study of calculations with a manufacturing center JL58, where the scheduled operations is 10 hours per day, that is 5 days per week, and manufacturing downtime due to meetings, material outages, and the training break and so forth is 14 minutes per week. Maintenance downtime and equipment breakdown is 227 minutes per week. So every single minute it costs, and that is why it is taken in minutes. And the theoretical cycle time is 0.5 minutes per unit. Production for the week is equal to 4450 units. Defective parts made is 15 units. So we can calculate P as 3000 minutes per week and D as 637 minutes per week and T as 2363 minutes per week. So you calculate and see what is A, E, R, and E. So target equipment effectiveness should be kept as 85%. So how do we achieve this target equipment efficiency as 85%? So we, however, request green hats to start thinking about the problem. When we'll return, we'll discuss about the ideas. That is with the other hats, right? And green hat is like finding a possibility of doing things and keeping new ideas, right? So total predictive maintenance recipes like learn the new philosophy and promote the new philosophy, fund the training and train everywhere, identify areas of the needed improvement, formulate performance goal, develop implementation plan, establish autonomous work groups. So this is the recipe of total predictive maintenance to achieve 85% of efficiency, equipment efficiency, effectiveness, right? So life is the art of drawing sufficient conclusions from insufficient premises, as per Samuel Butler. So we need to understand what is happening inside any process to implement this total productive maintenance. So I hope everyone understood what is total productive maintenance and how to calculate this AER. Let us go for a recap of this AER. So AER is nothing but A is downtime loss measured by equipment availability, and E is nothing but the reduced speed losses. Poor quality losses is given by capital R. These three things put together, we get equipment effectiveness. So with the example, we could easily identify whether the product, the effectiveness, equipment effectiveness is 80%, 85%, or more than that, so that the productivity is higher. So this philosophy, we have 8 pillars that we'll be discussing in the next lecture series. Thank you so much.